Hello. So welcome everyone to the distinguished lecture series. Today it is my great pleasure to introduce C. Mohan from IBM Almaden. Mohan has spent 36 years at Almaden at IBM. He is very, very well known in the database community and way beyond for inventing the ARIES recovery management system. If you haven't heard about ARIES, you should. This is the standard recovery management system used today in old relational databases. Mohan received numerous awards. He received the ACM Sigmod Innovation Award, which is a top award given to a database researcher, and was one of the earliest recipients of this award. He is a member of the National Academy of Engineering. He is a fellow of IBM. A fellow of EEE, of ACM, I think I mentioned all fellowships. Not a long time ago, Mohan became interested in this new technology, blockchain, where IBM has a very strong presence. And today it's really super exciting to have somebody talking about a new technology who is a leading expert in the technology of database systems. So here is Mohan.
Thank you. Thanks a lot, Dan. Gives me great pleasure to be here. Believe it or not, in these 36 years, this is my first formal visit to UW. And obviously, he's a masochist because he suffered through 90 minutes of this presentation at VLDB, and he still insisted that I come here and give the talk. So hopefully you all don't blame him for making you suffer through the next 60 minutes. As it says over there, I originally gave it as a keynote at the ICDCS conference in June, and then the longer version at VLDB in Munich. The URL that you see at the bottom is where you'll find different versions of these slides and even links to videos and so on. The good thing is that this is being videotaped, so soon I will post the link to this presentation also. I have lots of slides, but let me try and get through as much as I can. This is the full-blown version of the presentation as I presented it at the VLDB conference. I've tried to make the presentation be of use to not just geeky people, but even people who are totally new to the whole concept of blockchain, as well as non-techie people who are interested more in the use cases rather than the technical details. But at the same time, I try to make even the techies get something out of it so that they don't start yawning and all that stuff. So hopefully I'll live up to some of these expectations I've set myself. But I also wanted to make the point that at least after I got involved in this big time about a year ago, and so by no means am I an expert in this space, I noticed that the mainstream database people, as well as distributed systems people, have not really been paying attention to this space. Yeah, there are distributed systems people who are more, if you like, fringe people who do these things in, very specialized kind of conferences. But the general community, like in ICDCS, there were like 2 papers or something like that, even though there were gazillion papers overall. So that was the other intent, to make the mainstream people get involved, because even in IBM, none of the mainstream database people were involved in this, even though IBM started working on it like 2 years ago. And as a result, you will see some non-relational stuff being used, things like that, NoSQL, for example. We invented relational in SQL, but here it is supporting key value store and things like that. So I'm trying to fix that as part of my much more deeper technical contribution with a group of people, and I'll refer to it later. So in terms of the history, of course, a lot of people credit this anonymous person, Satoshi Nakamoto, as having come up with this whole concept of Bitcoin and so on. But believe it or not, just this morning I was reading an article in one of the recent issues of ACMQ, and that's Arvind Narayanan and somebody else who have given a history of where all the ideas of Bitcoin came from. So I highly recommend that paper. I forgot to put a reference to it today. But that work was done in what's called the open or permissionless environment, where anyone, anywhere can join the fray without having to reveal their identity and things like that. As I say at the bottom, I don't really care for that. And by the way, even though I'll be making strong statements and so on, and I've been a long time IBMer, whatever I say is all my opinion, not necessarily IBM's opinion, although it might be IBM's opinion, but I don't want to. There are various organizations, especially in Silicon Valley, where I've spent 36 years of my life, that are salivating at the idea of making money through ICOs and this and that, and all sorts of cryptocurrencies and such. I don't really care for any of that, and I'm not the make money quickly kind of guy. Otherwise, maybe I wouldn't have stayed in IBM 36 years. But this technology has taken the world by storm. In fact, there's a book that father and son team, the Tapscotts, have written, where they are characterizing this as the second coming of the internet. And they are really pretty much, I would think, talking more about the private blockchain rather than the public blockchain. What's the difference? The private one, you have to be admitted to the party before you can take part in the transactions of such a network. Whereas in the public one, you don't have to be explicitly admitted, and hence you don't have to reveal your identity and so on. So that means that in the private one, Byzantine behavior shouldn't be that much of a concern. Yeah, there could still be bad players and all that, but you know who they are, and so you can go after them. Just like Uber driver or this or that driver kind of people in the world today. Reputation and all that will be affected because their identity is known. In terms of practical deployment, the private blockchain has been deployed as early as February of this year, and that was for a private equity fund management in the Guernsey Island off the British coast. IBM worked with this company in Chicago Northern Trust to produce the application software. The important point there is that the transaction rates are low. The value of the transactions is high, but the rate is low because it's private equity. And IBM and its partners, who together in the context of this Hyperledger consortium, came up with this one project amongst the many projects in that consortium, the Fabric. They have released, as of July, the version 1.0 of that piece of software, which is open source and free for you to download and this and that. And that's considered ready for prime time. There were two prior releases, 0.5 and 0.6. There are some significant differences between especially the 0.6 release and the 1.0 release that I'll hopefully get to later. And IBM, separately from this free software that you can download and do whatever you want with it, has a blockchain as a service offering, which is now called the IBM Blockchain Platform, which obviously you have to pay for because it's running on the IBM cloud, and believe it or not, it's running on the mainframe, running Linux operating system, which has got super duper features compared to Intel's SGX in terms of secure execution environment and things like that. And that's the one that previously used to be called the HSBN one. And that's available in many places as it's listed there. And I'm not going to talk through every bullet point. I'll let you look at it. Meanwhile, a few months ago, Microsoft released what they call the COCO framework. I will say a few words about it. I don't claim to fully understand the very high-level claims that are being made over there. And Oracle joined the consortium, the Hyperledger consortium, back in August. And in October, they've announced, similar to the IBM blockchain platform, an Oracle blockchain cloud service that they have said sometime next year will be available based on version 1.0 of the Fabric. And also in October, one of China's largest companies, Baidu, has announced that they have joined the Hyperledger consortium as a premium member, which even Oracle didn't choose to do, which means you have to pay more money and things like that. And the market is estimated to be like 7.74 billion by 2024. Who cares about the exact number, but it's the order of magnitude that you should take to heart. And as I said, I care more about the private or permission blockchain systems and not all this other hoopla that's going on with Bitcoin and all the speculative stuff. And people think the world's hunger problem will be solved, and all sorts of exciting things are being mumbled by people who are spending a lot of time working on stuff like that, trying to fly under the radar in terms of, bypassing the governmental controls, this, that, and maybe we'll have a disaster like the 2008 financial disaster, thanks to many other people trying similar tricks before. This is just a laundry list of topics that people have worked on, including I myself, since I joined IBM. Byzantine Agreement Protocols and such we were working on in Almaden in '82 with Barbara Simons and Ray Strong and Danny Dolau, who was a visitor, and people like that. And I even worked on combining two-phase commit protocol, presumed abort, and presumed commit with the Byzantine Agreement Protocols that were developed in the lab at the same time. And then there are many other things that have happened, and a lot of those things have relevance to what I'll be talking about. In a similar sense, a bit before I joined IBM is when System R and SQL work was done. I joined the RStar project when it was midway through its existence, which is the distributed version of System R. And then a whole bunch of things happened, replication and OLAP versus OLTP and shared nothing, shared disks, and all the debates that went on there, as well as stored procedures and object-oriented databases, and then the more recent hoopla with NoSQL and MapReduce and Hadoop and all this kind of stuff. And of course the cloud and such, which all have relevance in this context, as you will see. So what's the problem we are trying to solve with these private kind of blockchains? If you look at a scenario like what's depicted here, where you are shipping something from one country to another, there are many parties that are involved. And even if they are all using computers, there's a lot of point-to-point kind of communication that goes on, but there's no single source of truth. So each one has its own database, and they might exchange messages, but nobody is able to get a good grip on what all is being worked on and what the current state is and things like that. And also, even now, there's a lot of paper documents that are in use, and attempts are also made to, if something goes wrong, go and fudge the documents to shift the blame to somebody else, and it's hard to prove that the people post facto went and changed the original documents. So many such things exist, and this leads to a lot of inefficiency and expensiveness and vulnerability and lack of transparency and such. So the attempt with the blockchain way of doing business is to do things in a more methodical way, where the programs that are executing in the different nodes will all be collectively developed and agreed upon, and there'll be stamping of the different transactions by the parties that are agreeing to the transaction being done in a way that later on they can't claim that they didn't agree to it. And also the databases that are going to be used will be shared and replicated, and the state changes will happen in a very thoughtful manner and all that, okay? It won't be the case that it's all some random set of programs that are independently developed that are running all over the place. Of course, this means that there has to be more discipline with respect to how people go about their jobs. They can't just let things the way they are. Just by installing the blockchain software, magically, suddenly everything will improve. Okay, so on the left, you see in many situations something like a clearinghouse being an intermediary. This happens even with house purchase, right? You have the escrow company and things like that. But in the right-hand side way of doing it, you are going to now have this digitally signed and encrypted transactions, and there is a ledger in which is like a bank ledger or a transaction recovery log, where you are doing append-only entries which talk about who agreed to what and which transactions were done when, and which transactions committed, which didn't commit, and why they didn't commit, and things like that. This is not to say that the databases are immutable. It's only the ledger that's immutable. So this has to be clearly distinguished. The database can be in place, updated, and all that. Just like today, you have the recovery log, which we don't do any in-place update on, which is always appended to, but the database is updated in place. Similar kind of story. There's a lot of exploitation of cryptography and this and that. Sometimes even one-time usage of keys and things of that nature, depending on the particular use case scenario. And I don't know anything about cryptography and all that, but know enough to tell you that there's exploitation of various technologies going on, which is similar to what I had in the laundry lists at the beginning. And so IBM's blockchain platform, which is the service I mentioned before, not only has this Hyperledger Fabric, the free software, but it also has some other additional tools that are not available with the free version. Plus, there is another Hyperledger project, which is open source, called Composer, which is a higher level tool, if you like. It's somewhat like a 4GL on top of a database system, which allows you to more easily define certain things, and I'll get into some of the details later. And then you have, of course, on top the blockchain application. So there are a bunch of things like this that you get by going to a platform as opposed to just downloading the free software and doing your own bolting together and worrying about certain failure scenarios for which automatically backups being brought up and all that is not part of the open source version of the software. Okay, so there are various roles that are there in this context, which are different from, let's say, something like an application programmer, database administrator, system administrator, and things like that that you know of in the database context. And here you have blockchain developer, blockchain architect, regulator. These are like SEC and such people. And also membership services, because there's, remember I said you have to be admitted to the party before you can participate. It's those sorts of things that are dealt with by things like the membership service, which issues you certificates and public key, private key, and all this kind of stuff. And then, of course, you do need to hook up this blockchain system with your traditional backend systems where you do order fulfillment and things like that, SAP, whatever, right? IBM's transaction processing systems and things like that. And then, of course, the network operator is also there, which in this case, in the case of the IBM blockchain network, will be IBM. But in China, for example, this fabric is now available on the Ali Cloud, the Alibaba Cloud. There are things like that. And Microsoft also, and Azure platform, has many of these sorts of blockchain software available as a service, not necessarily with fancy features attached to it, but they're just letting you run it there. There are many things that go with a blockchain solution. I won't spend too much time, but the smart contract, which is a generalization of what was done originally in Bitcoin, which was just managing this one thing called the Bitcoin, to something more general, which is managing any kind of asset, whether it's a digital asset like a music recording or a movie, to managing even physical assets like diamonds and such, or packages in that scenario that you had before. The digital representation of the physical things, obviously, right, was due to the Ethereum guys who came up with that generalization, right? But as we'll see later, Ethereum had its own problems which were inherited from the Bitcoin way of doing business, and we'll discuss that later. But there are other things like systems management, the notion of events and things like that over here. The Composer, as I mentioned before, provides you higher level tooling to define various aspects of a blockchain application plus the server-side software. Things like defining the assets that are being managed. There is an asset registry, the kinds of transactions that are going to be executed, buying and selling and transferring ownership and all that. And then you also have the business network participants, which are the organizations that are part of this network, and within each of those organizations, who are the users, and so on, who can do what, all the access control and authorizations for invoking transactions and things like that, which are no different from really, in a database system, you have similar things also. So, was there a question? Yeah.
It's a little hard for me to understand where this runs. I mean, like in classic database terms, when I actually commit a transaction, there's some like single event.
We will come to that. Okay, so the question being asked was, the gentleman has a problem figuring out, compared to a traditional database system, exactly when does a transactions commit and all that get finalized. Hold off on that question till I get into more of the details later. I was just trying to give you a very high level view, and then I'll get into some of the details. So just to delve into a bit more of the detail, if you look at just one of the peer nodes, not a whole bunch of nodes, when the application which is running on the client side, which is dealing with GUI, this, that, which is also developed by the blockchain developer in addition to the server-side software, which is the smart contract, which you can think of like a stored procedure. When the client starts a blockchain transaction, it does so by providing some input parameters to one of the smart contracts. Each smart contract in turn might invoke other smart contracts, right? But ultimately, when control goes back to the client, is the end of the blockchain transaction. And I would like to believe that each blockchain transaction maps to a corresponding database transaction, okay? But we'll come to that. So as the smart contract executes, there are events being emitted saying this smart contract got invoked, that smart contract got invoked, and also the smart contract, in addition to invoking other smart contracts, also makes database calls, like here it's shown in the sort of key value store API, get, put, delete, and so on, which is mucking around with this database that's listed here. But in addition, you have this blockchain, which is like, as I said, the transaction recovery log, but it's got a lot more in it than a typical recovery log. It looks very different. In a typical recovery log, multiple transactions writes will be interspersed, whereas here, each transaction is described by itself, and it includes not just the writes, but even the reads. And we'll see the details of how that happens later. So the way this works, the initial execution results in what's called the simulation of the transaction execution. But the client gets back something which it can use to later on figure out whether the transaction ultimately committed or aborted. Okay, it gets back a handle. And we'll see details of how that happens a bit later. But it is this blockchain, which is a set of sequential blocks, that is the immutable part. And unlike in the open blockchain, where blocks can go in parallel and things like that, because there are multiple people who are successful in adding blocks, here you will see that it's very deterministic, and there is no ambiguity about what is the next block that gets added and things like that, okay? And in terms of application areas, they are all over the place. They are not restricted to only the financial industry. There are diamonds being managed, there is supply chain and global trade digitization, food safety. Walmart and IBM have been working in China, farm to fork, IoT, you name it. Everything under the sun is being now dealt with via blockchains. And here is the reference to the book. By the way, on that page that I referred to at the very beginning, there are many papers that I referred to, and white papers and so on. Like I said, there is low volume stock trading also, like the Japanese exchange, which is different from that one that went production in early part of this year in the Guernsey Island. And what else do I want to tell you? There is also asset management that IBM itself is doing using the blockchain, where you have to look at many things like manufacturing records, shipping records, finance records, order management records, and things like that. It's a big mess, really. And the hope is that by using blockchain, a lot of it will get streamlined quite a bit. And there are more details about the kinds of transactions and events. In the Middle East, believe it or not, Dubai and Abu Dhabi are really competing with one another to leverage blockchain, especially in the government context, to enable, as Dubai has declared, by 2020 to make all the government operations paperless. Essentially, they want to put on the blockchain all the things that an Emirati citizen is eligible for, and as long as you can prove who you are using biometrics and such with a national identity scheme, then everything else will be there, and you walk into some hospital, whatever, social security service, whatever the equivalent things are, and they will know exactly you are eligible for 50% discount, you are eligible for free service, blah, blah, blah. Okay? So that's the sort of thing, and there are various aspects of the government that are very actively prototyping these things and so on. This has not gone production, of course. So all across the globe, it's also believed, even in countries like India, that with all the corruption and this and that, blockchain way of doing business will in fact bring about a lot more transparency than the hanky-panky things that go on with traditional ways of doing business. And so it's for that reason also I get really annoyed when people want to enable the hanky-panky with all this cryptocurrency and this and that, where they want to go under the radar and not be subject to some of the regulations and so on that fiat currencies are currently forced to deal with. There are many consortia in the context of which a lot of this work is done. So it is still chaotic because there's no such thing like a SQL standard in this space. It's still not as bad as the NoSQL arena, because in NoSQL, essentially each of the companies has its own way of doing database stuff, whereas here at least it's a bunch of consortia that are doing their own thing. So the number of consortia is a lot less than the number of companies. And as it happens with many of these sorts of things, companies want to hedge their bets. So it's not like JP Morgan is only in the Enterprise Ethereum Alliance. Guess what? They're also in the Hyperledger Consortium. So they are hedging their bets because they don't know which horse is going to win. So be careful when you choose which software you choose to deploy, because if you bet on the wrong horse, you may get messed up because there is no standard and you have to rewrite your app and all that. But in any case, the latest kid on the block, as this American Banker article said, even as of February, and I believe that's still true, is the Enterprise Ethereum Alliance. And I'll get into some of the details later. So there was a very nice paper in this year's SIGMOD by National University of Singapore guys and some of their colleagues elsewhere, which tried to come up with the first ever benchmarking framework for, they said private blockchain, but they have already, they've so far covered only one private blockchain, namely the Hyperledger Fabric, but they have done the evaluation also of Ethereum and one other thing, which is still an open blockchain. But the model is kind of nice to look at in terms of having a consensus layer where there are different ways of doing things, proof of work being the expensive, wasting MIPS, and in this green conscious world, what Bitcoin chose to do and what Ethereum followed with. And then there are other improvements like proof of stake and PBFT, which is what Barbara Liskov and company did with the practical Byzantine fault tolerant, which the Fabric used in the previous release, but in this release, the Fabric people have gone with just Kafka, which is PubSub. And also the contract itself may be written in some specialized language. People have come up with even specific languages for the smart contract. And even the execution environment in terms of the VM and so on, they've defined specialized ones. And then, of course, the database layer, there are different kinds of systems being supported. In terms of various architectural choices, at this point, it's fairly chaotic. There isn't a systematic study of why some group chose one way of doing business versus another way with respect to many things. Do you keep all the data in the blockchain, or do you keep only the hash of the data in the blockchain, but the actual data is kept in an off-chain database? What does that do to if the data gets messed around with in this off-chain storage? Yeah, you can detect the fact that it's being messed around because the hashes don't match, but you can't get to the original data. So how good is that? Whereas with the blockchain way of managing everything, you have so many different copies that even if one copy or a few copies get messed up, you still have the pristine version somewhere else. And there are many other things, assumptions about what kind of faults you are willing to deal with and so on and so on. So a longer version of the SIGMOD paper by Beng-Chen Ooi and Kian-Li Tan is like a survey of these things, the National University of Singapore guys. In terms of comparison, there are many hours I could spend talking about the different ways in which replication has been done, even in database systems in the past. And so one is the primary copy update, where you do the update in one place, then you use the log produced at that site to, as if you are doing restart recovery, apply the changes in another place. But these two systems have to have the exact schema, exact version of the database, and so on. The second one says you capture from the log the changes that were done, and then you create SQL statements out of it, and then re-execute them. So now the schemas can be different. It can be DB2 here, Oracle here, and things like that. The third one is what my dear friend Mike Stonebreaker thinks is the greatest thing since sliced bread, which is this whole silliness of each transaction being executed serially, one at a time on the primary, and then you capture the SQL statements on the primary and then redo them. it has all sorts of problems. He never bothers to tell you what all the problems it has. Things like it can't handle non-determinism. If a long-running transaction, is executing and a short one, a high priority one comes, there's no such thing as interrupting that longer one, blah, blah, blah. Many, many problems that we all have had to deal with over the decades. Goal-oriented scheduling, blah, 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 parallelism up the wazoo being leveraged. All that is thrown to the winds because in each partition, he does one transaction at a time. And so it turns out in the blockchain way of doing transaction ordering, there is some amount of randomness that's deployed where transactions, as you will see as I give the details later, get ordered fairly randomly without any method to the madness. And this could result in, if you have conflicting updates being performed, the first of the transactions in a block that does an update to an object succeeding and all subsequent ones getting blown away. Whereas if you had done it the traditional database way, all of them could have succeeded if they all started in the primary copy. And then even if they all conflicted on everything, they would have been done one at a time and then they would have been redone in that same order elsewhere. But by upfront doing what we call the simulation in the fabric in parallel and then putting them all into a block, you lose out in terms of concurrency. So these are some of the issues that I would like to be seeing dealt with. So this is the benchmarking thing. I won't dwell on this that the Singapore guys did, which is the one where they've done something like TPC benchmark for the blockchain environment. They have various queries, if you like, that exercise different components of the system, namely the application layer, the execution engine, the data model, the consensus layer, and so on. And they come to some conclusions, but for the fabric, they use the previous release, the 0.6 release, and they are revising these numbers, and I'll find out more when I'm in Singapore in the next 4 weeks. So they have compared in the paper, Sigmod paper, Ethereum, Parity, and Hyperledger. And they have a framework in which you can plug in other systems of this kind. And so that's their contribution, and this paper will get cited forever because it's the first such thing. So this is a nice kind of paper to write, So now let's come to Ethereum. So as I said, Ethereum guys are the ones who generalized the Bitcoin to the notion of managing any kind of asset using the blockchain, but it still had these problems because of using proof of work, which is solving a math problem, blah, 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 and wasting lots of energy, and also this possibility of things going in parallel and multiple branches being there and so on. They also have this notion of gas for charging. And of course, the JP Morgan guys had internally done some work called Quorum, which they were using as a closed source within JP Morgan, which tried to take Ethereum to the private domain. And they then early this year decided to contribute it to open source. And that forms the basis for the Enterprise Ethereum Alliance. It has some significant differences compared to how the Hyperledger Fabric does its thing. So just to give you an example, they have a single blockchain. They have the notion of public state and then private state. The private state involves only subsets of the nodes within your network. The public state is visible to everybody in the network. So we have something called the channel concept, which is you have a network of n nodes. Subsets of the nodes can form a channel, which is like a Venn diagram, and they can be overlapping and all that. In our case, the database as well as the blockchain associated with the channel is completely disjoint from those associated with every other channel in that network. Whereas here they have this single blockchain in which all the transactions are being recorded, but then they say only the public state's data will be in its full-blown glory in the single blockchain, but for the private one, they have only some hashes here. So in other words, the private state is not redundant. So if you blow away all those private state copies, you are messed up because the blockchain doesn't have it. Whereas in our case, the database is merely a cache of the latest version of the data that's talked about in the blockchain. So you can blow it away, and you can start from the beginning of the blockchain, and you'll be able to reconstruct the entire state that got blown away. So I still don't quite understand how this thing is intended to function in a similar kind of context. But anyway, this is what they've done. This is what I meant by saying There are all these different approaches being taken. It's high time somebody in a more systematic way evaluated these things. Yeah.
Sorry, I'm having trouble understanding why exactly the private state is not redundant. It's my understanding what you just said was that the private state was still stored on the log in some fashion, maybe encrypted. But you're saying they actually have some out-of-band method to...
No. Okay, so the question was, isn't the private state data in the log itself? But I'm saying if you have like a bomb being blasted on that private state version of the database and you don't have the traditional recovery log and all that to recover, or somebody clobbered that data in whatever way, they took over that site and so on, the blockchain itself doesn't have the data explicitly, because the claim was that they wanted the private thing. In this case, for example, if you look at the green private state, it's participant 2, participant 1, and regulator. These other guys are not part of that private state for green, right? They didn't want the actual data to be in the blockchain, because then these other guys would have visibility to that data. In our case, this is a non-issue because the blockchains are separate for the separate channels.
What does exist in the log then?
The log is something orthogonal. Don't worry about that for the time being.
In the blockchain?
In the blockchain, in which case?
In the private state case, what actually exists?
Oh, the hash is what they said.
Okay, it's providing it.
Yeah. They don't have the actual data, but the hash. But for the public state, they say the actual data is there. This is what I've gathered. This is another problem with this whole open source, blah, blah, blah space. Documentation is pretty pathetic. People think, they can just say, hey, go look at the source code. That's like an excuse for not doing a proper documentation. So I'm really tired of not being able to get proper answers in many cases. And even the documentation, if it exists, is not necessarily matching the code. And it's not even clear if the code is documented within it, comments, it's necessarily consistent with the actual code as it evolves and so on. So yeah.
Yeah. So in the case of the Hyperledger, when you were saying the state channels are separate blockchains as such, right?
For each channel, the blockchain and the corresponding databases are disjoint from any other channel's blockchain and database.
So if you think about a many-to-many relationship there, and each one has different relationships with every...
Like I said earlier, when I described channels, it's like a Venn diagram. I can be in a channel with Dan, and I can be in a separate channel with Ed, and then there can be a third channel which involves all three of us. But as of now, we don't allow transactions to span channels in terms of update transactions, because that will need two-phase commit and all this kind of stuff. At this point, we are only allowing read access to other channels' data under appropriate authorization conditions, but we don't allow updating one channel as well as another channel's data in a single blockchain transaction, if that's the sort of thing you're getting at. Okay, thank you. Okay, so Hyperledger Fabric, IBM initiated this early last year by contributing open source code to open source, and it's gone through significant changes, especially between 0.6 and 1.0, by introduction of this concept of channel, which didn't exist before. Once you got admitted to the party, you got to see everything that's happening within that network. And people said, hey, that's not good enough. So imagine, this is much more restrictive thing than this. Anybody anywhere in the world can see the open blockchain kind of notion. And also it turned out this introduction of the channel concept allowed for greater scalability and things like that. I don't have the time to go through all that, but like I said previously, we used PBFT for consensus, but for performance reasons, and I don't know what other reasons, because I wasn't party to this decision, Kafka is being used in this release. And so that's what this is talking about. Of course, it improves performance clearly, because PBFT is still expensive. But we are allowing for pluggable consensus layer as well as database layer. So if you want, you can plug in these other things. There are different kinds of, so the smart contract is also called, for whatever reason, chain code in this Fabric software. There are system ones and regular ones, which are not too different from catalog tables in relational versus user tables. So you can imagine, The system ones are the ones that are used to deploy user chain codes. And then key value store is being used, and optionally in this release, CouchDB is also allowed, which is a document database. There are more things here. I'll let you look at this. I want to cover this important thing, which is the three-stage execution of a transaction in the fabric, which is the client invokes, as in that original picture I showed, it sends the transaction to a few endorsing peers, a subset of the peers in that channel. Exactly how many and all that is all application design consideration. They execute this chain code, maybe potentially more than one. They produce the reads that were performed. I mean, they track the reads that were performed. The updates are not actually sent to the database system, but they are trapped. This is like an optimistic execution of a transaction. They capture the read set and the write set, and they send it back now to the client. The client compares these different ones it got for that same transaction. It's the same chain code being executed everywhere. Because of concurrency and all that, they could wind up giving different results, or because one party agrees, the other party doesn't agree, and so on. It's really up to the application semantics as to what this all means. If they all agree, then the next step is the client sends all this stuff, including the signatures of the endorsing peers and so on, to the ordering service, which in this case is Kafka, remember, who just takes many such transactions that were given to it, and puts it into a block, orders them randomly. This is where no intelligence is being applied in terms of analyzing the read and write sets and try to minimize number of aborts or any of that kind of stuff, or the amount of wasted work and so on. And then it sends now this block of transactions to everybody. The original guys who executed some of these transactions have amnesia. They don't record persistently anything of that simulation that they did. Now each guy steps through one transaction at a time without communicating with one another. They check whether the read set is still in the same state in their version of the database. If it is, then they say the world hasn't changed with respect to that set of data. So without executing the smart contract, they can just take the write set information and plonk it into the database. In this case, validation has succeeded and the transaction has committed. If the validation fails for any reason, some data has changed. Originally, you asked for all San Jose employees, you got 8 of them. Those 8 might still be the same, in the same state. But guess what? 2 more San Jose employees have shown up in between. So now the answer is different. So again, validation fails. In which case, this is like a transaction getting aborted. It's really up to the client to figure out what the heck to do next. Typically, they'll resubmit the transaction. But the point is, it takes a long time before you figure out that some transaction is getting booted. And that's the inefficiency of this whole thing. And this is where I said, if any subsequent transaction after a particular one that changed an item changes the same item, you are guaranteed that these following ones will get blown away. Because as part of updating, performing the update during commit, you are upping the version number or whatever that's tracking the state of the different items. More details. If you really want the details, you can also go look at some of my other videos. And yeah.
I'm trying to understand what's new. And
well, this particular way of doing is definitely new.
Well, so I mean, particularly what's new. So presumably in databases in the past, there had been a write once log that you didn't ever delete. If you wanted to be able to reconstruct your database, you would have some log that...
No, okay. So I didn't realize that's where you are headed. Okay, hold on. So if you compare this with traditional workflow management systems or business process management systems where multi-party transactions have been done, first of all, it's not as systematically done as here in terms of the same chain code running in different nodes, the same work being done in parallel in multiple...
Yeah, so if the argument is, I don't mean to interrupt, but if the argument is that the database is being executed by multiple parties who are...
Not database, it's the code. It's a smart contract. Don't get confused between the database, which is being used in a fairly dumb way here, versus the logic that encapsulates the business rules of engagement, which is what the smart contract is. It is what traditional workflow, the high-level diagrams we all draw in a workflow management system, or you can think of it as stored procedures.
I mean, we had extensible databases in the past too, so I'm just...
Yeah, but those were more theory than real. I mean, we can have a long conversation about extensible databases, but it's still not the same. Believe me, the languages being used, even as I said much earlier, Kotlin, all sorts of languages have been defined to express the semantics. They don't let you, for example, look at where the moon is and what the current time is and so on, because that will show up as different values in the different endorsing peers. So all sorts of restrictions are placed on what you can do in that smart contract because they are trying to get deterministic execution. Okay, that's why I said even that Stonebreaker way of doing business is a problem, because if you had a RAND function call invocation in your application's invocation of SQL, and you capture that and re-execute it in another place, the results are not guaranteed to be the same. Whereas the log way of doing replication, which I discussed, it's the after effect of any randomization, that you did, that gets captured in what actually happened in the log, and that then becomes a source for cranking out SQL, which gets re-executed elsewhere. But still, it's all whatever you can express in SQL and such. Whereas here, there's a lot more in terms of signatures and this and that comes into play that's not in a traditional database way of doing business. In any case, it's the higher level specification of these rules of engagement that is very different from different organizations writing their own application programs and they exchange messages and communicate and so on, which is old way of doing business. Let me just quickly run through it because he's getting nervous since so there are more things we talked about here, how the fabric layer is tracking. The fabric layer between the chain code and the DBMS is the one that in the fabric is tracking the read and write sets, not the database system. And in particular, the reads are sent during simulation to the database system, and the writes are not. They are trapped in the fabric layer. Essentially, this means that fabric layer has to be all knowledgeable about whatever the database primitives that are being supported in the chain code. And that can get really messy once you start allowing SQL there, which is what my project is doing, okay? So this is, from various perspectives, a bad idea, making this layer on top of the DBMS behave like a DBMS. And it introduces other complications also. You can look through the details that I've got here. So I just wanted to flip through a few more slides. R3 Alliance is yet another one of these consortia. They do allow relational language to be used. They do have some higher level concepts that they talk about. Contract execution is deterministic, and its acceptance of a transaction is based on the transaction's contents alone. A transaction is only valid if the contract of every input state and every output state considers it to be valid. So they have this notion, if you like, something like referential integrity and other kinds of constraints that you have in a database system associated with these objects and so on that are being managed using this. The fabric, as far as I know right now, doesn't have such higher level concepts. And they also have some other things that I just don't have the time to talk about. But in the extended version of the slides, you will find more things there. They even keep track of history of transactions, which transaction followed which transaction, and they even keep hashes of all this in a way that you cannot tamper with. They have notions of notary transactions and things like that, just like you have notary public, people being made to certify transactions that are, third parties and so on. Intel has a project which they initiated called Sawtooth, which is one of the many projects in the Hyperledger Consortium. And this is the one where they are trying to leverage the SGX, the secure execution environment thing that I referred to before, where I said the mainframe IBM one is even more super duper and so on. In the IBM one, for example, the whole fabric peer and everything can be run within the secure execution environment. It turns out Intel has a lot of restrictions on how much memory and storage you can associate with this secure execution enclave. So you are not able to run everything over there. So what that means in the mainframe is that even the operator cannot look at the data or muck around with the functions and so on, the code itself. because it's so that much hidden away from such people. But they do have this notion of concept of transaction family, transaction dependencies and such. Anyway, so more things. Microsoft, as I said, announced something called the COCO framework. For whatever reason, they say this is like a layer on top of any blockchain system you like. And for whatever reason, they've chosen to leave out the Fabric. They have Sawtooth, but they don't have Fabric. Maybe because they think, oh, IBM is associated with it. Let's not put that there. I'm not sure. Because they claim, they can accommodate anything. But in the picture that they have in this August report they put out, they show Ethereum, Quorum, Corda, and Hyperledger Sawtooth. I still haven't quite figured out what added value this provides. It's not like it's actually like a common language on top of all the weirdo languages each one of these things has. But they make some tall claims like, oh, this will allow you to have super duper transaction rates and so on. If you haven't really mucked around with the insides of any of these things, I don't know how on top you can do something that suddenly produces magic. So I have to admit, I only recently realized this report had come out in August, so I haven't done my homework digging through the details of the report. I don't know if anybody from Microsoft is here. Anybody? No? Or nobody wants to admit? Oh, okay. So this is what my current project is doing. I'm not able to give you the details right now. Essentially allowing where it said get, put, delete, we will be allowing SQL statements. You might think, big deal. Guess what? It has lots of ramifications because we didn't want to make now the layer in between this smart contract and this ledger become all-knowing about SQL. And it's non-trivial, by the way, because it's not just the select statements that need to be sent to the DBMS if you follow the same old pattern. Even for IUD statements, insert, update, delete, they might embed a subselect, insert from subquery, delete where, blah, blah, blah condition, update where, blah, blah, blah condition. Imagine now you have to carve out that portion of the read portion of these IUD statements, and you would have to send it. This means you better understand fully the semantics of all sorts of complicated SQL. And also, you cannot do this if you are going to allow a stored procedure which runs on the database side to be invoked, because then the Fabric is not there to police all the database calls that will be made. So on and on. I can spend many hours talking about this. But in terms of futuristic topics, there are many things that are open, as I say at the bottom, numerous research possibilities for database and distributed systems people in this, what I call the new era of distributed computing. As I mentioned earlier, when it comes to this channel notion, we are not allowing multi-channel transactions, especially not updates that touch more than one channel. In terms of how many endorsing peers should be there in a network, in a channel, and for any given transaction execution, what subset of those endorsing peers should be involved. By the way, the major distinction between endorsing peer and the other peers is that the endorsing peers have the smart contract installed in them. The other peers are merely tracking the database changes. They don't have the smart contract in them. So which subset of the nodes should be involved in a given transactions execution? What should be the logic? Dan is an important guy. He has to bless every transaction. Whereas amongst the three other people who are involved, it's enough if majority agree. Things like that. We don't have a cookbook that we provide to you today on what the right things to do there are. These are like, how many indexes to have, how to partition the data, all the typical database things that we postponed working on for years and years, long after relational was invented originally, right? Same sort of thing. How to deal with non-deterministic actions. As I said, so that gentleman asked the question about, hey, can't you do all this within the context of the database system? There are people, even at Microsoft, who have done in a more single database kind of context, adding certain features, and there are other people in IBM looking at this also, adding features to the database system itself to introduce the notion of something like the blockchain, where tables can be only appended to. There are things like that with multi-version tables, what we call bitemporal tables, but they don't have all the other attributes of keeping the signature of who modified it and so on. We might have something in the log, but we don't as part of the database itself, keep track of these sorts of things.
Yeah, it just seemed like if I was trying to build a high assurance database, I would have had those features in it to begin with.
But
they didn't. Okay, that's good.
Yeah, but guess what? Over the decades, even logging of reads is almost never done. If at all it's done in a separate audit log, not in the traditional recovery log. And in spite of all the fancy things that the Orange Book and this and that the DoD guys have, right? Oracle forever supported many of these Orange Book kinds of levels of security and so on. Still, many of the things that we are talking about in this context, in spite of the 4 decades of relational work that's gone on, has not been done. Again, this is not to say we cannot, now that we think of all this, go and add these things. And as I say, people are actively working on this, even the IBM India Research Lab guys. In fact, my goal was to first do what we are doing now, which is leave the overall execution framework the same in the Fabric, but just allow for relational and do the things more efficiently with respect to the Fabric not having to become very knowledgeable about SQL and so on. And learn from that what are the right things to do and all that, and then talk about not keeping the overall model sacrosanct and actually do more of it within the DBMS and not have to have a whole lot of other stuff on top. I think I'll stop here. My throat is messing up. Okay, thank you very much. Appreciate it.
So I know time is, but maybe we can take 2 questions before people leave. Yes, Paul?
So in this process of endorsing, there's computation and participating and being part of a consensus. And if it's you've got many different players in your example, what is the incentive for one of the players in a fairly complicated blockchain channel to endorse things that don't directly involve them? In Bitcoin, you understand you get a little bit of Bitcoin back when you're...
Okay. So first of all, the question was, in the way this whole thing works in the Fabric, this notion of endorsement or the first phase, which is simulation, what's the motivation for somebody to do anything at all? First of all, remember, this channel concept is based on those parties being part of this multi-party thing, the business process, whatever. So there isn't such thing like some random guy is being asked to do something. So these are organizations that are working together. This is not some Joe Blow off the street that you are trying to make him do something. So I don't think there's any comparison with this whole open blockchain way of doing business where there's all this notion of incentive and all that. This is part of your job effectively, that these programs have been written by all these parties that are in that contract jointly. Okay, so really that's basically it. So if you look at, for example, the scenario I had at the very beginning, these are the customs agents and the shipping guy, the forwarding agent, the exporter, the importer. This is their mainline job. It's not like they are doing something for their entertainment or some such thing.
So, private permission blockchain. So private permission blockchains, people are still like in there. They could be still potentially bad actors in there. And public blockchain, you need 51% compute power of the total nodes to modify any transaction. With this, how many endorser nodes do you really need before things start getting messy in a channel? Is there anything straight like that?
First of all, bad players, as I said at the beginning, with Uber, whatever kind of environment, will ultimately get nailed and they'll get kicked out, okay? So it's not like people can behave badly and hide under something or rock or whatever. So that's first order of business here. We know who you are. So if you misbehave, we'll come after you. And these are typically organizations. Like I said to this gentleman, it's not some guy off the street that we are talking about, right? These peer nodes are owned by different organizations, exporter, importer, as I just rattled off. So if they do misbehave, remember, the transaction, for it to be accepted, there is this endorsement condition that can be specified. That's where I said, today we give you the tooling to say that, but we don't give you a way of figuring out what the right thing to say is. So you can say things like I said, Dan is an important guy, he has to bless every contract. Amongst the 3 others, it's enough if the majority agree to it. Those kinds of specifications we let you provide, but we are not giving you right now a cookbook to say this is the recommended thing in this condition, in this kind of application, in this other application, this is what's the right thing to do. But in any case, the whole point is we will do the things only if there is enough agreement. And exactly what that means is left up to the application designers. So this whole 51% and all that, I mean, there are people who are talking about, the server farms up the wazoo in China can go and, this whole assumption that the longer chain will keep getting extended. They can try to screw that one also and extend the shorter chain. All sorts of nonsense that's going on with all this open blockchain that I was, complaining about all this with some of the people I met earlier in the day. I can spend many hours. I've been debating all this with various people in various fora. And so I'm not convinced that any of that is such foolproof thing because there are bugs in that software. People's money has been stolen. So sometimes people make it appear like it's somehow, completely error-free and there's only goodness that can come from all these sorts of assertions that are typically made. But there are enough disagreements even amongst the Ethereum guys about how to extend the block size and what to do with forking and this and that.
Yes, folks, I have questions too, but we're running out of time, and we have a reception right now.